All right, let's dive deep into something I think a lot of people want to refresh on. Radical expressions and equations.
Yeah, those can be tricky.
Well, the material we have today covers four main things. Simplifying radical expressions, how to add, subtract, and multiply them, and then,
Solving radical equations.
yeah, solving radical equations. And then, of course, we have those rational exponents.
Right, right.
And I think this is going to be really helpful to people.
You know, it's interesting because radicals, they kind of pop up in places you wouldn't expect. Like, have you ever thought about those old pendulum clocks, how they keep time?
I mean, not really, no.
It's all based on the swing of the pendulum, the period, and it's actually a radical equation.
Oh, wow.
It's specifically the square root of the length of the pendulum is a part of that equation.
Oh, that's cool.
Yeah.
So it's not just some, abstract math concept. It's actually applicable to the real world.
Yeah, absolutely.
So let's start off with simplifying those radical expressions. Seems like the key here is prime factorization, right?
Oh, for sure, for sure. Think of it like breaking down, some complex molecule into its basic atoms.
Okay.
Right. So we've got a number under the radical. Find its prime factors and look for pairs. And for every pair we find, we can pull one factor out of the radical.
Yeah.
So it's all about kind of cleaning things up, making it as compact as possible.
All right, so let's take the square root of 50 as an example. How would we go about simplifying that?
Okay, so square root of 50, the prime factors of 50 are 2, 5, and 5.
Okay.
We've got a pair of 5s, so we can pull one of those 5s out, and we're left with 5 times the root of 2.
Okay.
Much nicer.
Much needed, yeah. Okay, so we've kind of tamed those individual radicals.
Right.
What happens when they start interacting with each other? How do we add or subtract them?
Okay, so that's where things get a little bit interesting. We can only directly add or subtract radicals if they have the same number under the radical sign, which is called the radicand.
Right.
So it's like combining terms. You can combine 3 square roots of 2 with 2 square roots of 2.
Right.
But you can't directly combine a square root of 2 with a square root of 3.
Okay, yeah.
They just don't mix like that.
That makes sense. So what about the multiplying radicals?
Okay.
Is it as restricted?
Multiplying's a little more forgiving.
Okay.
You can multiply any 2 radicals together. The numbers under the radical signs, they just get multiplied together and stay under the radical sign.
Gotcha. Okay, so we've simplified, we've added, subtracted, and multiplied.
Right.
Now, how do we actually solve equations that have these radical expressions in them?
So solving radical equations, it's a bit of a delicate operation. The goal is to isolate the radical term, and then you raise both sides of the equation to the power that's going to eliminate the radical.
Okay.
So that might be, squaring both sides if it's a square root, or cubing both sides for cube root, and so on.
So you're just undoing that radical.
Exactly.
Okay, that makes sense. Now let's talk about those, I think we call them mysterious rational exponents.
Yeah.
How do they fit into all this?
Think of them like a different language for expressing roots. So instead of the radical symbol we're using, we use fractions as exponents.
Oh, interesting.
So the square root of a number is the same as that number raised to the power of 1/2.
Right.
And the cube root is raising it to the power of 1/3.
So it's just a different notation.
Different notation.
Same concept. That's pretty cool. Well, I think we've really covered a lot here today.
Yeah.
From simplifying those radical expressions all the way to those rational exponents. And it seems like the key is that even these really complicated math concepts can be broken down into steps if you understand those basic principles.
Yeah, definitely, definitely. And as you keep going in math, think about this question. Why is it that we can express roots using both radical symbols and fractional exponents?
Mm-hmm.
What does that tell us about how math works and how all these different concepts are connected?
That's something to think about.
Yeah.
Well, thanks for joining me on this deep dive.
You got it. It was fun.
I think everyone learned something today.
I hope so.
All right.
Yeah. Tay 99.